Hello there. So today we'll be going over the last 11 questions of the 2019-20 General Math Test 1. So let's start with question 39. Kevin saw a baseball hat that costed $16 and then the next day it's $2 off. It's asking for the percentage of change, the percent of change. So normally when you have a problem like this, what you do is you take the change and then you divide that by the original value. So because it's asking for the percent of change, you keep 2 and then you divide that by 16, which is 1/8. That's equal to 0.125. It's asking for a percentage, so you multiply by 100 and you get 12.5%. That's answer choice C. Now 40 is giving us a function and then it's giving us the domain, a specific domain, and it's asking us for the specific range. So a domain is basically all the x values of that function. It's all the x values, and then the range is correspondent to the y values. So when the domain is -6, 0, and 8, it means the range is the output of those three values, those three inputs. So that means we have to plug in -6, 0, and 8 into the function, and then we get our specific range. So if we plug in -6, we have 5 times -6 over 2 minus 3. That's equal to -15 minus 3. And that's equal to -18. Okay, so our range set has to have -18 in it. And the only one that does is answer choice E. But normally, if it asks for more, then you'd plug in 0 and you'd get -3. And then you'd plug in 8 and you'd get 17. Cool. 41 asks about the growth factor in the exponential growth function. And then, so an exponential function is in the form of a times b to the power of x, where b would be the growth factor. And so 6 times 1/4 to the x power, 1/4 is the growth factor. Now, if you were to see, let's say a compound interest equation, then you'd have the y equals your principal times 1 plus the rate to the power of time. Here, 1 plus the rate would be b, so that would be the rate of the growth factor. Okay. Now, question 42, which of the following is a linear factor of the polynomial? That's a quadratic. Now, you could solve it using p over q. Well, not solve, you could factor it using p over q, where you take the factors of c and you divide by the factors of a. And when I say c and a, what I mean is a quadratic function is y equals a times x squared plus b times x plus c. So that would be a, that would be b, and that would be c. Now, we're factoring. It's asking for linear factor, and that just means a factor. So when we factor a quadratic, what we need to remember is that a times c, the factors of that have to add up to b. And so the most obvious factors are 12 and -10, but those don't add up to 7. So you just have to kind of play around with the factors until you find something that works out. So then I find that if I have -8 and I have +15, well, that multiplies to -120, and that adds to 7. And so what I'm going to do is, now I know the components of b. I know how to break up b. So I can either do the box method, or I can factor by grouping. So I'll do the box method first. Basically, the box method, you keep in your ax squared here. So that's going to be 6x squared, and then you keep your c value here. And so that's going to be -20. Then your b value goes in these two boxes, and we already broke it up into the components. So you have positive 15x, and then you have negative 8x. These add up to 7, positive 7. So then that has your b value, and you've broken it up into components where you can now factor. So what we're doing is, if we isolate this part, that row, then we see that we're trying to pull out the greatest common factor. So in this case, the greatest common factor of 6x squared and 5x is going to be 3x. Now, if we look at this row, what's going to be the greatest common factor? It's going to be, well, even before you look at the greatest common factor, what you should look at is 3x times whatever goes there is going to equal 6x squared. And so we're trying to find what equals 6x when you multiply by 3x, and that's going to be 2x. So you have 2x there. So now it's pretty much just multiplying across. So if we look at this, it's got to be a product of 2x and whatever goes there. And so that would be negative 4. And then if we look at this, it's got to be a product of 3x and whatever goes there. That's going to be 5, positive 5. Right? And then just to make sure, these two have to multiply out to that. So negative 4 times 5 is negative 20. That means these are your linear factors. You have 3x minus 4 times 2x plus 5. Of the answer choices, the only one that has that is answer choice B. But you can also factor by grouping. So let me show you that. Factor by grouping. We already got our two components as negative 15x and negative 8x. Grouping is very, very similar to the box method. It's just instead of drawing a box, you kind of do it in your head. So you have 6x squared, right? You add 15x, and then you subtract 8x, and then you subtract 20. That's your constant, equals 0. So factor by grouping, you group just like two sets of, I guess, components or stuff like that. And so you group it, and then you pull out the GCF. So we already found out the GCF of 16x squared and 6x squared and 15x is going to be 3x. And then inside we have 2x plus 5. And then just double check to make sure that it multiplies out 6x squared plus 15x. So now, over here, we're trying to find the GCF, but we need to make sure that whatever's in the parentheses here is also in the parentheses here. Okay? And I'll tell you why after we find it. So the GCF of negative 8x minus 20, that's going to be negative 4, and then you're left with 2x plus 5 on the inside. Now, the reason that these two have to be equal, the two parentheses have to be equal, is because if we want to find like the 2 or 3 linear factors, if we want to find it through grouping, we need to use the distributive property, right? So we have 3x and negative 4. But like, how do we combine that? Well, through the distributive property. We know that 3x minus 4, all of that times 2x plus 5 is equal to that. Right? And so we get to the same answer as there. But normally it's not like this, but you can also group it in a different way, right? So let me show you that. So let's say I grouped the 6x squared, negative 8x, and then I grouped the 15x and 20. So let me rewrite it that way. So 6x squared minus 8x in one group, plus 15x minus 20. So in this scenario, it's going to work. It might not always. So then you do the same. You pull the GCF out of both of these, and so on here you have 2x as your GCF, and you're left with 3x minus 4. And then here you have 5x as your GCF. You have 5 as your GCF, and you're left with 3x minus 4. So then using the distributive property, you have 2x plus 5 times 3x minus 4 equals 0. Those are your linear factors. Okay. Now question 44. It's a system of I skipped 43. So 43 is talking about the multiplicative inverse of the product of 4 and 2/5 and 3 and 3/4. So let me make some room. Okay. So 4 and 2/5 and 3 and 3/4. These are mixed fractions, but pretty much it's 4 plus 2/5 times 3 plus 3 over 4. Right? That's what a mixed fraction is. So you could always like FOIL it out and stuff like that, but that would just take way too long. So instead of writing it as a mixed fraction and multiplying those, what I can do, because it's asking for the multiplicative inverse of the product, so we need to multiply anyway. So what I do is I take the improper fraction. So you have 4 and 2/5. What is that saying? You have 4 whole and then 2/5. It's a part. So if I were to convert this, right? 4 whole, that's equal to 20 over 5. And then you have 2/5. So you're getting a common denominator pretty much. And so you have 22 over 5 as your improper fraction. And like normally the way I was taught, you take the whole number, you multiply it by the denominator, and then you add it to the numerator. So 4 times 5 is 20, plus 2 is 22. Okay? And then just to confirm, you can see that 22 over 5, and you can convert that to to a mixed number, and you can get 4 wholes, and then you're left with 2/5 as a remainder. So it works. So now you have 22 over 5, and then you convert 3 and 3/4 to an improper fraction also. So then you have 15 over 4, and you have 22 over 5, and you're multiplying. So with multiplication, it goes across, straight across. Multiply numerator by numerator and denominator by denominator. So on the bottom you have 20, and on the top you have 330. It's asking for the multiplicative inverse. Let's simplify before. So the product of those two numbers is 33 over 2. The multiplicative inverse, you flip it. So it becomes 2 over 33. That's your answer. (44) is referring to a system of equations. It's asking for the solution of that. So let's look at this. A system of equations, pretty much, when it's asking for the solution, these are lines, if you didn't realize, right? These are lines. So it's not in y equals mx plus b, but these are lines because you have y and x. So you can rearrange to make it y equals mx plus b. So basically the solution of a system of equations is going to be the point where those lines or those functions intersect. And so we're trying to find where they intersect. One of the ways to solve a system of equations is like through addition and elimination. So what you can do is you have this and you have that. So you're trying to cancel out one of the variables, so you have one variable to solve for. And then you can plug that value back in to solve for the other variable. So how would you like cancel out one of the variables, and which one's the easiest? Well, for me, I see the negative 4y and I see 8y. And I see if I multiply the whole bottom system of equation, the whole bottom system by 2, then I can get negative 8y, and I can add straight down and cancel out the y's. So let's do that. I have 9x plus 8y equals 1. And on the bottom, I have 4x minus 8y equals negative 92. And remember, you're multiplying throughout the whole thing. You're just scaling it up. So then if I add this, I'm left with 13x, the y's cancel out, plus 0y equals negative 91. So if I divide by 13, x equals negative 7. Cool. It's asking for the negative coordinate of the solution. solution being x, y, x comma y, the coordinate point. This is a negative solution, so E is the right answer. But if they ask for like the y coordinate, all you'd do is you'd plug -7 back into any of the equations. So I'd plug it back into the first one. 9 times -7 plus 8y equals 1. -63 equals plus 8y equals 1. 8y equals 64 by adding 63 on both sides. Y equals 8. So then your solution would be -7 comma 8. So at the point -7 comma 8 on the coordinate grid, these two lines would intersect. Question 45 is asking us to solve for x. So before I do that, let me kind of tell you what this is. You'll see the lines and you may be like, what are those? Well, this is signifying an absolute value, right? So what is an absolute value? Pretty much whatever's inside the lines is going to be positive. So I have the absolute value of -23. That's going to equal 23. And then like the absolute value of 23 obviously is going to equal 23. So it just makes whatever's inside positive. So now if I were to ask you, right, can like the absolute value of something be negative? Well, it can't. Just like by definition, the absolute value makes something positive. So unless I have like a -1 times the absolute value, it's not going to be negative. So this is just not true. It's not like possible in a real sense. Now, if I asked you to solve for like the absolute value of x equals 32, let me like walk you through something. So if I said like the absolute value of x equals 2, right? It's going to be like, obviously the absolute value of 2 is equal to 2. But the absolute value of -2 is also going to be equal to 2. Why? Because the absolute value makes whatever's inside positive, just regardless of anything. So the +2 is by default, it's positive. -2 becomes positive, right? So now if I need to solve for x, what do you see? You see x is equal to -2 and +2. So in other words, x is equal to plus or minus 2. Now if I were to delete everything in the middle, right? You have the absolute value of x equals 2, and then the solution is x equals plus or minus 2. So what do you see? Well, I see that I can get rid of the absolute value if I make it plus or minus on the other side. So I have the absolute value of x equals 2, then x is equal to plus or minus 2. That can help us solve this problem, but before I get there, I wanted to talk about one more thing. If you had like 3 minus 4 times the absolute value of x times like 5, okay, equals like 3. I'd have to bring everything other than that. I'd have to isolate the absolute value. This is the absolute value, and I'm going to isolate it by using algebra to bring everything else over to the other side. So I would, I'd subtract 3, and so I'd have -4 times the absolute value of x times 5 equals 0. And I just wanted to let you know, the absolute value pretty much acts like parentheses. So whatever is inside, you do that first, and then you move on. So then I divide by 4, multiply by 5, or whatever. It's 0 over here. So even if I divide by -4 and multiply by, even if I divide by -4 and -5, you have the absolute value of x is equal to 0, which means x equals plus or minus 0, x equals 0. Okay. Just remember that the absolute value has to be isolated before you can make the opposite side plus or minus. So now you have the absolute value of x equals 32. Based on what I just told you, x has to be equal to plus or minus 32. Solve for x. This is your solution. 46. What is the side length of a square with a diagonal measure of 16 inches? This will bring me to a couple important concepts. One, you need to know the Pythagorean theorem. If you don't know what that is, that's a squared plus b squared equals c squared, where you have a right triangle. It has to be a right triangle. Your hypotenuse is c and your legs are a and b. So in any right triangle, the square of a plus the square of b is going to be equal to the square of c. So now it gives us a square with a diagonal measure of 16 inches, and then the side, it's asking us for the side length. So let me draw it. So we have a square. The diagonal is 16 inches. Okay? So what do we know about a square? Well, we know that all four sides are equal in length. We know that they have right angles, all four angles. Okay? We also know that the diagonals are, by definition, the diagonals are going to be of equal length. But for now, we don't need to worry about the other diagonal. So we know that all the sides are of equal length, and it's asking us for one of the sides. So let's just label it. Each side is defined by the variable a. Or I can just make it, for simplicity's sake, this side is b, this side is a. Because what I'm going to do now is I'm going to delete this other part, and you're just left with a triangle, right? You don't need to worry about the other part of the square because you're trying to find the side length, and all the sides are of equal length. So with the Pythagorean theorem, we know that a squared plus b squared equals c squared. So I just told you this side is a, that side is b. This has got to be c because it's the hypotenuse. Hypotenuse is opposite from the right angle. And we know that a is equal to b. But let's just write it. A squared plus b squared is equal to c squared, and c is 16, so it's going to be 16 squared, right? So a squared plus b squared is going to be equal to 256. So now we know a is equal to b, so we can use the substitution property to substitute a in the place of b. So we have a squared plus a squared equals 256, so combining like terms, you have 2a squared equals 256. You can divide by 2 on both sides. You have a squared is equal to 128. Then you take the square root of that. Okay? But it's plus or minus on the other side. Whenever you take the square root, it's going to be plus or minus. So you have a is equal to plus or minus the square root of 128. 128 is going to be 64 times 2. And because 64 is 8 squared and we're multiplying inside, you have a is going to be equal to plus or minus 8 times the square root of 2. Okay? We know a is equal to b, so b is also equal to 8 times the square root of 2, plus or minus. But in this case, having a negative length doesn't make sense. So you're going to go with positive 8 root 2. So the side length of the square is going to be answer choice C. But one of the concepts I wanted to get into, we know that the side length of the square is now positive 8 root 2. So we also know that the triangle side length is going to be 8 root 2. So what else do we know about this triangle? Or just in general triangles, what do we know about them? The sum of the angles in a triangle is going to be 180 degrees, right? So that angle plus the right angle is going to be equal to 180 degrees. Which means, like if you subtract 90, the sum of this angle and that angle has to be equal to 90, right? So now, what are these angle measures? And how would you know that? Well, I mean, if you took geometry or you just kind of studied triangles, you know because these side lengths are the same, this is an isosceles triangle. You can kind of imagine it like this. This is an isosceles triangle, which means that the corresponding angles are congruent. So that angle and that angle are congruent. So what this means is that the remaining 90 degrees is evenly split. So each angle is equal to 45 degrees. So what's important about that? Well, just look at the pattern, right? You have 8 root 2, 8 root 2, and then the hypotenuse is 16. So like what's the significance? How do you get from like say 8 root 2 to 16? Well, if you add 8 root 2 and 8 root 2, it doesn't really like work out. You don't get 16. But 16 is going to be 2 times 8. And how do you make like 8 root 2 into 16? Well, you have this square root of 2. And you know that if you square the square root of 2, that's equal to 2. And that will multiply 8 to become 16. So how do you get from 8 root 2 to 16? You multiply by the square root of 2. Same over here. So in a 45, 45, 90 triangle, one of the legs is equal to the other leg. And then if you multiply it by the square root of 2, then you get your hypotenuse. So if we didn't use numbers, right? And let's say this side is defined by the variable n. This is also n. Then the hypotenuse is going to be n root 2. This is a special triangle. It's one of the like defined triangles with easy to remember defined like side lengths. So the sides opposite from the 45 degrees are always going to be equal to n. Like they're going to be of the same value. And then the hypotenuse is going to be n times the square root of 2. So like if we were to kind of like reverse engineer this problem, how you do it is you have 16 equals n times the square root of 2. You're trying to find n because that's like the side length of a square. So you divide by root 2. And then you have to rationalize. So you have 16 over root 2 because you can't leave the radical in the denominator. And so you multiply by root 2 over root 2. Because anything over itself is equal to 1, you're not changing the value of the fraction. You're just changing the numbers. So you have 16 times the square root of 2 over the square root of 2 times the square root of 2. So you're squaring the square root of 2, which is equal to just 2. And so that's 8 root 2. We come to our same answer. There's another triangle you should know about. It's called a 30, 60, 90 triangle. And the side lengths of this type of triangle are the side opposite to the 30 degrees is going to be of length n. The side opposite to the 60 degrees is going to be of side length n root 3. And then the hypotenuse is going to be of length 2n. Remember the 30, 60, 90 triangle and the 45, 45, 90 triangle? These are really important. So now it's asking us to simplify 47. This brings me to exponent rules. So the first rule is if you have a times some a to the power of n, m times a to the power of n, that's equal to a to the power of m plus n. Okay? So 2 to the power of 2 times 2 to the power of 3, that's equal to 2 to the power of 2 plus 3, which is 5. So it's 4 times 8 equals 32. 2 to the 5th power is 32. The second rule, a to the power of m divided by a to the power of n. That's equal to a to the power of m minus n. So let's take the same examples. 2 squared over 2 cubed. That's going to be equal to 2 to the power of negative 1. So before I solve that, let me bring you to my next rule. If something is to the power of a negative exponent, so a to the power of negative m, that's equal to 1 over a to the power of m. So you flip it. Like if you had 2 to the power of negative 1, that's equal to 1 over 2 to the power of 1, which is equal to 1 over 2, 1/2. But let's say you had 1 over 2 to the power of negative 1. Right? What would happen then? You still do the same thing. So it's 1 over 2 to the power of 1. And that's when you're dividing by a fraction, it's the same as multiplying by the denominator. So it would just be equal to 2 to the power of 1. You're pretty much flipping it when you have a negative. And so what that's telling us up here is that 2 to the power of negative 1 is 1 over 2. Okay? And if we were to like just solve it in a different way, you'd have 4 over 8, and that is equal to 1/2. Next rule. A to the power of m divided by n, when the exponents are divided. That's equal to the nth root of a to the power of m. So 2 to the power of 2 over 3 is equal to the cube root of 2 squared, the cube root of 4. Likewise, 2 to the power of 3 over 2 is equal to the square root of 2 cubed, which is going to be equal to 2 root 2. If you had like 2 to the power of 4 over 6, simplify your exponents first. So you have 2 to the power of 2 thirds, and that is 3 root 2. Okay? I think my final rule is going to be the power of a power. Okay? When you have a to the power of m, all of that quantity is to the power of n, then that's going to be equal to a to the power of m times n. 2 squared, all of that cubed is equal to 2 to the 5th power. 2 to the 6th power, sorry, because 2 times 3 is 6. So it's going to be 4 cubed, that's equal to 64. 2 to the 6th is equal to 64. These are my rules. So then if we come to the simplified problem, just off like the first thing I can see, I can divide 20 and 5 and I get positive 4. A to the power of 3 divided by a to the power of negative 1. Right. So I told you that when you're dividing the same base with exponents, you subtract the exponents. That's rule number 2. So now what you do, a to the power of 3 minus negative 1. Okay? Times, same over here, b to the power of negative 2 minus negative 4. Okay, you could think, yeah, like, couldn't you like flip the denominator and numerator and do it like that? Yeah, you could. But when you're dividing like this, I mean, you can also just subtract. So if you don't know what I'm talking about rule number 3. Anything to the negative power, it's 1 over that. So let me do it that way. So b to the negative 4th, that's going to be 1 over b to the 4th. So that's just b to the 4th power. And that's over b squared because this has a negative also. Okay? And then you have c to the 1st power divided by c to the 3rd power. So then you subtract. You have c to the power of 1 minus 3. Okay? So then that would be equal to 4 times a to the 4th power b squared, because you subtract 4 minus 2, times c to the negative 2nd power. So that's equal to 4a to the 4th b squared. And then because it's to the negative 2nd power, it's 1 over c squared. So over c squared. 4a4 b2 over c2. That's answer choice D. 48. If pi equals 3, what is the circumference of a circle with that equation? Okay. So it's saying pi is equal to 3 just to make it easier for us. It's asking for the circumference. Okay. This equation, x minus 7 squared plus y squared equals 256. That is resembling the standard form of a circle equation. So the standard form is going to be x, it's going to be x minus h whole squared plus y minus k whole squared equals r squared, where h comma k is the coordinate for the center of the circle. Okay, and then r is equal to the radius. Okay, so over here you have x minus 7 whole squared, which resembles the first part, and then you just have plus y squared, but y squared is equal to y minus 0 whole squared, right? And that's equal to 256. Now sometimes you'll have to like group it together and factor it so that it resembles this, but for now we don't need to do it, and when we will, then I'll probably go over it. So you have x minus 7 whole squared plus y minus 0 whole squared equals 256. It's asking us for the circumference of the circle, so we will be concerned with the 256 part, because 256 is equal to r squared. So plus or minus the square root of 256 is equal to r squared, the square root of r squared. So r is equal to plus or minus 16. But it wouldn't make sense for there to be a negative value of 16 as your radius. So it's just going to be positive 16. So what does this mean? It's asking for the circumference. The formula for the circumference is 2 pi r. We know pi is 3, and we know the radius is going to be 16. So that's going to be 96. 96 will be your circumference when you multiply. That is answer choice C. And then from this equation, you know that the center of the circle lies at the coordinate 7, 0. Okay? (49) If 4x minus 1, that gives us this, and it's asking us to find that. It may look hard, but it's not, because it's not a system of equations. It's just there's only one variable, and that's x. So what I would do is I would multiply by 3 on both sides and by 2 on both sides to get rid of the denominators. So I'm essentially multiplying both sides by 6, because 3 times 2 is 6. And so this would cancel out. 6 divided by 2 is going to be 3. And then 6 divided by 3 is going to be 2. So we have 3 times 4x minus 1 equals 2 times 3x plus 4. Twelve x minus 3 is equal to 6x plus 8. You subtract 6x and you add 3 on both sides. And then you get 6x is equal to 11. X is equal to, well, it's equal to 11 over 6. But it's asking for 12x minus 7. So you don't need what x is equal to, because you have 6x. You know that 2 times 6x is equal to 12x. So that means 12x is equal to 22. and then you subtract 7. That's going to be equal to 15. So the value of that is B, which is 15. What is the length of x below? That's convenient because we just went over 30, 60, 90 triangles, didn't we? So 30, 60, 90 triangle, I told you the side opposite to the 30 degrees is going to have a length of n. So x is equal to n. Then the side opposite to the 60 degrees, I know it's 60 because 30 plus 90 is 120, and 180 minus 120 is going to be 60. The sum of all the angles in a triangle has to be 180 degrees. So the side opposite to 60 is going to be n root 3 in length, and then this would be 2n. I don't need to worry about this, but I'm trying to find x. So I know that 2n is equal to 2 root 20. So n, you divide by 2, that's going to be equal to root 20. Right? None of the answer choices say root 20. Why is that? Because you can simplify root 20. Because root 20 is equal to the square root of 4 times 5. And so 2 squared is 4. So 2 root 5 would be equal to n, which is equal to x. And with that, we conclude test 1 of the 2019-20 season.